Hey guys, it's me again. Um, Today we have a power supply, another power supply from this time not a Samsung TV, but from a Sonya Bravia TV, if I'm not mistaken. Or not Bravia, sorry, Vizio. A Vizio TV, which is Sony, if I'm not mistaken. And basically, just like the other power supply that I uploaded the video about, this thing, it's pooped, it didn't work. It had basically, well, actually, no, not that it didn't work, sorry. It wasn't totally dead, but I'll explain to you what the issue was. I wish I could have actually started filming really from the get go because this one actually technically I already repaired, but I wanted to show it to you guys anyways to see if maybe, to show you if maybe if you guys have a similar issue in the future, you can maybe fix it yourself, you know? So basically, the issue of this power supply was I was reading my, let's see, where is it? My 5-volt standby, which is going to be on this header here. And I'll show you over here. So this connector, which corresponds to this legend, pin 1, 5-volt standby. And I was checking my pin 1, and I was getting some voltage, but I was not getting steady voltage. Basically, my power supply was fluctuating. And yeah, the power supply was fluctuating, and the rest of the power supply didn't work. It wouldn't turn on, whatever, blah blah blah. So basically, that was the issue at hand, and I'm gonna show you now where the issue was and how I kind of managed to find out where the problem exactly was. So the issue was basically in this area over here. I was testing these components or these capacitors, and I don't think this one, but these two, they were testing shorted. So basically, 0 ohms, 0 continuous beep on the meter. So there was a short across these caps, and that should not be the case. Any of these caps here, there should be no short on them, but it was in this case. So I pulled the leg off the cap on each one to see if maybe the short would go away. It didn't go away. So testing, and then even before that, before I even was testing around here, I was checking our primary side, right? And the primary side, this is why it was tricky, because the primary side, I was measuring my main voltage here, my 100, I think it was 60 almost volts DC, and that was fluctuating as well. So the secondary side, the output was fluctuating, and the primary side, the voltage off the main cap, was fluctuating as well. So in a situation like this, you really got to take your time and trace and test and pull components out and test again until you find the problem. So that's basically what I did. So I was testing, and I was checking over here also, because this is our PWM circuit, by the way. This IC over here, this is a, I don't know who the manufacturer is, but this is a 2, if you see, let's see, where's my camera? If it's going to focus, I don't know. It's a 2A153D PWM chip. So there's a data sheet online for this IC, and it gives you typical circuit whatever diagram. So it's pretty much, that's what I was looking at, and it's the same thing here. They have a similar circuit laid out, and but everything here was okay. The fuse tested okay. All these components were testing okay. So there was nothing really wrong with them. And then that's when I went on to the secondary side, and I was like, it is fluctuating here, which it's not supposed to. But then I said, let me go to the other side and let me start testing, because it could be that the problem is on the secondary side. Although we do see the same thing happening on the primary side. So I went to the secondary side. And then, yeah, as soon as I tested these caps here, I don't know about this one. I'm pretty certain it was just these two. As soon as I tested these two, dead short. And I was like, where could be the short? The problem I knew wouldn't be here, because when I measured my voltages here, there was nothing. This is the driver circuit over here with the transformer. This is the driver circuit for the backlight of the TV. So this was reading 0, and I highly doubted that the problem was here. So I kind of canceled that section out, and I was focusing over here. And I also kind of canceled the fact of the primary side. I was like, everything looks good, so I don't think the problem is on the primary side. You know, so then I focused my attention over here. And then when I went here, these are barrier diodes. And these are 150 volt, 5 ampere barrier diodes, Schottky diodes. They tested all three shorted because these three are in parallel. So, what did I do? I pulled one leg off, tested it, was okay. Went to the next one. Pulled one leg off, tested it, was okay. Pulled one leg off, tested it, dead short. And I'll show you exactly which diode that was, because I actually still have it here. And I hit the floor now. Shoot, where did it go? I'm going to get this diode, and I'm going to set up my meter, and I'm going to show you how I knew it was dead. Okay, so just to show you guys that I knew that this diode here was bad, basically what I'm doing is I'm testing the diode with my multimeter, but what I did when it was in circuit was I just pulled one leg off, and then I used the same setup more or less to test to see if this diode was bad or not. So if I put it to continuity mode, watch what happens. It's a dead short. This diode is no good. Dead short. And that's basically what was happening in the circuit. This was shorted somehow. Maybe from a surge or something. I have no idea. Customer said that there was a surge at some point, so it could have been that it killed this. Sometimes it's, you know, just a bit too much current goes through and it pops for whatever reason. The other two are okay. Again, just I pulled each leg off one by one, and I found the faulty one, which was this guy here. So it's a bit tricky because these are in parallel, right? So it takes only one to make it seem all bad. So you really got to go one by one, test them individually to find out where the fault is. So this guy was the culprit, but the one thing that I will record that I didn't have a chance to do, but I will do it now, is I will put a new diode in that I ordered online, and we'll get this back to the customer, and he should be very happy with this repair. Actually, right before I put the new diode in, I just wanted to show you guys, because technically speaking, since it's missing, it will still work, the power supply, but we have to be careful with the load that goes on it, because now we made, how can we say it, we degraded the power supply a little bit in terms of capacity wise, so we have to make sure that we do put this diode in, because that's how the design was. You know, you don't just take components out saying you don't need it, because it doesn't work like that. There's a reason why there's a diode there, you know, so for one reason or another. But just to show you guys, now I have it powered on and everything. I have the cord attached. If I look at my standby pin, 5.09 volts, 5.10 volts. Our standby is returned. So with the short out of the way, we have our standby voltage. It is present again. And if I was to test the other side, which I'm looking, I'll do this on camera live. I'm going to take this guy off. And I'm going to put him on here. There you go. So I attach that. You're going to see that we have our 160 volts DC present. This is from our main caps there, our main filter caps, our big caps over here. I'm testing it here because the trace comes all the way down here to our PWM chip, and then it gets thrown over to the other side on the secondary side. So if I measure it again, we can see we have our 163, 164 volts DC, and it's not fluctuating crazy, because before this was really fluctuating badly. Like it was really going up and down, you know, so there was no stability whatsoever. So this is okay now, once again. And yeah, so we're going to put the new diode in over here, and I know the power supply works, but I'll even test it. I'll power it on like I did with the other one, And we're gonna measure our pins also to see if we have our other supplies, like our what is this, our 5 volts, 12 volts. So let us put the new diode in, and we will test those voltages afterwards. I thought I would show you guys actually right before I put the diodes in. Here's the diodes I ordered. These are Schottky barrier diodes, and of course I ordered them from DigiKey. And this is the part number for those who are curious. Schottky 150 volts, 5 amperes. So it's a weird number. Basically, it's a 5150. This is what it is. It has a weird numbering scheme for this manufacturer. Of course, it's made in China, because everything's made in China. So, yeah, this will work. So we're gonna take one. I have 10 of them, because I'm not putting 10 because I'm keeping some as spares. But I'm gonna take one, and we're gonna put it in the circuit, and we should be good to go. So I'll put this diode in the circuit, and we'll reconvene from there. Okay, guys, so I'm back. It's actually been about a day now since I recorded the last clip, so it's the next day right now. So, believe it or not, we are still having some issues with this power supply. As if I remember correctly, in the last video, or the last clip I should say, we tested the, I didn't show you yet the standby, but I showed you that this guy was shorted. This was the barrier diode, whatever, Schottky diode that went open. It won't focus, but anyways, it's a 5150 Schottky diode. It says SB5150. Yes, it's a 5150. 150 volts, 5 ampere Schottky diode. And it went open. So this one, we replaced it with the new part that I got from DigiKey, which is right here. This guy right here. This one here. So this one. So this diode was replaced, and I did some testing afterwards, and I got my 5 volt standby back. So my 5 volts is now working like it should. Alright, so we're back on this this power supply now. A couple of things have changed actually. So this whole entire video that you're gonna see now, it's been recorded over a couple of days, the past couple of days, and a lot has changed actually, and there was a lot of things that have been going on off camera. Basically, what I was having issues with, just to sum it down, I was missing my 5 volts over here on the secondary side. My standby wasn't present. Had to track down the problem. Turned out to be a faulty barrier diode over here. This is these Schottky diodes here. So one of them was open. So I was like, okay. I replaced the diode. 5 volts, my standby 5 volts came back. No problem. Then I was trying to test it to see if the power supply would turn on and, produce the other voltages that I need for this to work. And I wasn't getting anything. So I have my PS on pin here, I have it jumped, and I wasn't getting in this case I have 12 volts. It's the only measurement here that I can check otherwise. And I wasn't getting that, so I was scratching my head. I was thinking, what the heck is going on, And then I was doing all kinds of probing. I was probing the PWM-IC, which is right over here. It's on the other side, but the pins are here. The primary side I was looking around here, and then the secondary side I was looking around here. And then I was testing some of these octocouplers, and I ended up replacing one because I broke one of the pins by accident. So that's on me, but I managed to replace it without too much trouble. So, and it's the same spec and everything as the other ones and as the original. They're all the same part number on these things anyway, so I replaced that. There was no issue. Now, I have this powered up once again because I did find out what was the deal with this thing not working still, supposedly. And I have my probes hooked up here on the secondary side. So now I'm just going to show you my meter when I measure some of these pins. So I'm going to check my standby just to show you guys that I see my 5 volts again. We have 5.07 volts. So that's my standby pin. That's okay. And then the other two pins are This pin it means something over here. AC off detection. So basically some sort of detection pin. I don't know exactly. But if I probe that, is that the right pin that I'm probing? Yes. 5 volts, because I have a jumper, if you couldn't tell. I have a resistor here tied to my 5 volt standby, and I'll explain why for that in a second. My PS on, which is 5 volts, because it's jumped like the other pin to the standby, and my ground, which is 0, that's okay. And then this is going to read 5 volt standby once again. There you go. And this is going to be, that's going to be ground again. I know that's going to read 0. And then this guy here, I'm going to probe him from here because I don't want to short. Actually, I can probe him from here. I don't want to short anything. So right here, that should read 12 volts. Let's see. 12.20 volts. There you go. So our 12 volt supply is there. And then the rest are just stupid pins or whatever, meaning doesn't mean anything. So now I'm seeing all my voltage, and actually I'm seeing all my voltages, and I'll show you on the other side here. The other voltage I should be seeing is 24 volts. So if I probe it here, there you go, 24.15 volts. So this entire section seems to be working. So now I'll explain to you what the heck happened over here and why I was having maybe some trouble testing this in the first place. So this AC off detection pin here, it seems that it needs to be jumped to 5 volts to get everything working. We need the PS on wire like this jumped, and we need the AC off detection pin jump like this as well to 5 volts. Otherwise, we will not see anything. So, I don't know. I remember also another thing I wanted to say is, I said this is a Samsung power whatever supply, which it is. It says over here, again, if you look on the other side, it's upside down, but it says Samsung Electromechanics Company Limited or whatever. So you can see it's right there, all that writing. So yeah, it's a Samsung board. But it came out of a Vizio TV, which is interesting. Vizio, if I'm not mistaken, I guess I was wrong, because I thought Vizio was a Sony brand. Again, I don't know if that's always the case or not, but just from what I remember, I thought it was a Sony brand. So, but it turns out that it's probably not the case. I guess Samsung is making power supplies for Vizio or whatever. If Vizio is like maybe one of those not cheap brands, but like sub brands of another bigger brand, so. But this is for sure Samsung power supply board, because it says Samsung right on the board. But yeah, so our secondary side is working like it should. So for those who are testing these boards in the future, maybe this is just something that you can learn. Your PS-on wire has to be jumped like this, and your AC detection, AC off, whatever, blah, 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 AC off detection should be jumped to 5 volts. I have a resistor in place because I want to make sure I don't burn anything up or whatever, just in case. So that's why I put this resistor. This is a 1 kilo ohm resistor, so I don't want to short anything by accident or whatever. So that's why that resistor is there. So yeah, AC off detection and PS on both need to be jumped to 5 volts. Otherwise, you won't see your voltages. Now I'm going to go to the primary side, and I'm going to show you that the PFC actually, which is this IC right over here. This is the PFC IC. I'm going to show you that everything is working like it should. And we're going to take some voltages, and you're going to see exactly what I mean. So I'm just going to switch my probe to this side, and we're going to take some voltages. Alright, so now our ground is on the hot side, and we're going to measure across the big caps. I'm going to be careful not to short anything by accident. And as you can see, my probe is on the positive side of the cap. We are reading 390 volts DC. 389, 390 volts DC. And this is telling us that our power factor correction circuitry is working. Because if the PFC wasn't working, we would read on the multimeter 160, 170 volts. So that's just like the power supply being at idle standby. So that's just the power supply turned off. So when the power supply is turned off, this pin, I don't want to short anything, this pin should read close to 400, 390 volts. So this is okay. And when the power supply is off, that same pin should read 160 volts. So when none of these connections are in place, we should be reading 160 volts. So now I'm just going to show you quickly the PFC chip, and I believe it's going to be pin number 8 is the supply pin. So this should read above a certain threshold. So usually I think about 12 volts. If this pin number 8 on this IC reads above about 12 volts, then that means everything is working. But I know already that it's working because I saw 390 volts across the main cap. So I'm just going to do it here just to show. There you go. It's reading 11.84. So I think the minimum, I don't remember what the minimum is. It could have been 12, could have been something, but I don't know. It changes by IC. So I'm reading 11.84. And maybe if I go right on the pin, I should be seeing the same thing anyways. Yeah, same thing. So 11.84. So this IC is working because obviously then how the heck am I getting my 390 volts across the main cap? So this is working like it should. This IC is working like it should right over here. And then this IC over here, I'm not sure what it does, but everything is testing okay. This is the PWM IC, so if I look here, same story here. If I probe this should be reading 300 something. Yeah, see, here you go. 300, almost 400 volts. Now if I look at pin number 2 should be the supply for this IC, or not the IC, supply of the power for the IC. And there we go, we're reading 19.26, 1920 volts. So that's okay, that's working like it should. This IC is working like it should. This PWM IC over here is working like it should. Is there any other measurements can I take? I think this is just, again, the supply. I'm reading 20 volts here. Yeah, there you go. 20 volts. So this whole entire power supply, I think we fixed it. So I'm going to let the customer know that it's ready to be picked up, and he will be on his way, and hopefully his TV will be working. So if you guys like the video, please subscribe to the channel, leave a comment down in the bleep bloop section over there, and make sure you hit the bell so you don't miss any new videos that I upload. And if you like this sort of stuff, just stay tuned, because we're going to have some more content like this coming very soon. So take care, guys, and until next time, we will see each other. Okay, so bye for now.